This is a demo of inductive reverse engineering. So imagine you have some program that when you input hello, you get hello world. What we get back when we click update is a program space, or this graph that you see. And this program space has several program traces going through it, going from along these paths. So you can see in this upper path that we take the input 1 concatenated with the constant string world, while in the bottom path, we take the constant string hello and concatenate it with the constant string world. In both cases, we get hello world. We may want to introduce a new example of our program. So suppose now I say hola, and we get hola world. We update this, and again, we get our program space back. And here we see that we can concatenate our input with world and hola with world. Now when we go to intersect these together, what we see is just what is similar between the two, which is input 1 concatenated with world. So now if we say cool and evaluate, we get cool world. We can also add further inputs if we need to for our program. So suppose now we say that world is another input in our program that it takes. Now we update. We see a new program space that also represents this hello world, now allowing us for our second part of the output to be coming from input 2. Similarly, if we go into example 2 and we add, let's say, mundo, and replace world with mundo and update it, again, we get this program space that allows for input 2. Again, we intersect this now. We say cool and story. And of course, cool story comes back with a space in between. Now, let's say we want to do something a bit more advanced. Let's say we want to add the number 1 to our be our program. So suppose we take an input 1 and we say 1 plus 1 equals 2. We see the program space come back representing that. Now let's say we show an example of 2 with 2 plus 1 equals 3, and we update that. When we go to intersect these, we're going to have a problem. It's going to fail to synthesize. And the reason that it fails to synthesize is that it doesn't actually know how to do this plus 1 operation. All we're getting back is the constant 2 here and the constant 3 here. And the reason for that is that our theorist is very simple. It only knows how to repeat this data, where data is the regex of anything or a new line, and then also the non-function theorist, where the non-function theorist is just basically the identity function. And this is all represented in Python using the IR library. So if we want to make it a little more advanced, not much more advanced, but let's say we want it to be smart enough to do this plus 1 operation, we need to define how that would be done, currently programmatically. So let's say we do this to say that we want to be able to add 1 to every byte in our input. And then we want to say that data now is able to do this plus 1 operation. When we go back now to example 1 and we update, we can see now this 2 has also the ability to be our newly defined plus 1 operation. Similarly with example 2, if we update, we can now do this plus 1 operation. And finally, when we intersect, we will see we no longer have the issue. If we say 7 as our input, we evaluate, we get back now 7 plus 1 equals 8. So this is a basic demo of IR.